What's going on, everyone? Welcome back. Patrick here, moving on to the next video, another example dealing with trig limits. So we got the limit as x approaches 0 of 1 minus cos of 6x all over sine of 5x. So notice we can't make a direct substitution here because we'll have the denominator be 0, sine of 5 times 0 is sine of 0, which is 0. And notice also the numerator is going to be 0. We're going to have 1 minus cos of 0, because 6 times 0 is 0, but cos of 0 is 1, so we'll have 1 minus 1. So the numerator is going to be 0 as well. So we'll end up with 0 over 0, so we got to use a different strategy for this limit. And like I did in the previous examples, which I'm assuming you've watched up until this point, I'm going to be using these results to help us out, and more specifically for this limit, for this specific limit, I'm going to be using these two results here. This limit as theta approaches 0 sine theta over theta equals 1. And then this one, which we haven't used as much, but I'm going to be using it in this one. The limit as theta approaches 0 of cos theta minus 1 over theta is equal to 0. So the first thing I'm going to do is I'm actually going to take this limit and I'm going to split it up into two separate expressions. So I'm going to have 1 minus cos of 6x times 1 over sine of 5x. Now, if you remember, whenever we have sine of an expression, on the other side of the fraction, we want to have that same expression. So here in the numerator, we're going to want to have 5x, but we can't just multiply the numerator by 5x, got to multiply the denominator as well. So it's like we're multiplying this whole expression here by 1. So it's staying the same, we're just adding more onto it. Now also notice that here for this property we got cos theta minus 1 over theta. And notice here we have 1 minus cos of 6x. So to get it as cos of 6x minus 1, which would resemble this numerator more, we can factor out a negative. However, notice that we also want to have that same expression in the denominator, which we don't have here. So we actually want to multiply this by 6x in the denominator, but we can't just multiply the denominator, got to multiply the numerator by that as well. Okay, so I'm going to combine a bunch of things here. The first thing I'm going to do is I'm going to take out a negative from here, a negative 1. And then that negative 1 I'm going to take out of the limit. So I'm going to have a negative in front. Then I'll have the limit as x approaches 0. This now changes to cos of 6x minus 1, right? All these signs change. So it becomes this. And then this 6x, as I mentioned, I'm going to put under this numerator like that. So this goes away, this goes away. Then I'm going to take this 5x, put it over this sine 5x, so I'll have 5x over sine 5x. So this goes away, and then this goes away. And then notice we're just left with 6x over 5x, which notice the x's cancel out. So we're left with 6 over 5, which is a constant, which I'm also going to take out. So I'm actually going to put negative 6 over 5 in front. Because it's not just 6 over 5, it's negative because of that negative that I took out of this bracket. Right? So I skipped a couple of steps from here to here, but hopefully you get where this negative 6 over 5 is coming from my explanation. And now what I'm going to do is I'm going to use the limit law, because notice we have the limit as x approaches 0 of two expressions that are multiplying by each other. So using limit laws, we can create two separate limits that are multiplying by each other, with each of those separate expressions. So we'll have the limit as x approaches 0 of cos of 6x minus 1 over 6x, like that. And also the limit as x approaches 0 of 5x over sine 5x, like that. And now what I'm going to do is on the side here, I'm going to work with both of these limits separately. So I'm going to start with this one. So the limit as x approaches 0 of cos of 6x minus 1 over 6x. Notice that it's a very similar format to this, but let's fully finish it. Let's do a change of variable. So let theta equal 6x. Right, we're going to plug in the theta here, and notice how when x approaches 0 here, theta is also going to approach 0. Let's split this up so we're not getting confused. Okay, so when we do that change of variable, we'll have the limit as theta approaches 0 of cos theta minus 1 over theta. Just plugging in theta for the 6x's. And then this is that which is equal to 0. So this bracket, it actually ends up being 0. And we just showed the work right there. And then this bracket here, we got the limit as x approaches 0 of 5x over sine of 5x. Now notice that it's similar to this format, but not really. It's kind of flipped over. So we've done examples like this. Basically what you want to do is if you have a fraction and you want to flip it, you can just take 1 and divide it by the reciprocal of that fraction like that. So I'm going to take this fraction here and put it under 1. And when I do that, that fraction now flips. Like that. And now what I can do is I can distribute this limit to the numerator and denominator using limit laws. So I'll have the limit as x approaches 0 of 1 over the limit as x approaches 0 of sine of 5x over 5x like that. And then for this limit, on the side we can do a change of variable. We could say a is equal to 5x. You can use theta again. We already used theta for this limit, so I'm going to use a different variable. So a is equal to 5x, and then as x approaches 0 means a is approaching 0. So we would end up here having the limit as x approaches 0 of a constant is just equal to that constant, so it's equal to 1, over the limit as a approaches 0. Let's do that change of variable, sine of a over a, and notice that this is that, equal to 1. So it's 1 over 1, which is equal to 1. So this ends up equaling 1, that bracket. We just showed all that work there. And then from here, notice that this times 0 times 1, what do we end up getting? We end up getting a final answer of 0. So we haven't used this property too much, but this is an example of where you can use that property. So going through all these steps, you end up getting 0 as the final answer.